Okay, we want to start, just, it's not a quiz, just a few questions. Just to see where you are with square roots, okay? Can you tell me? What's the square root of 16? What's the square root of a squared? If you don't have a clue about some of these, just say so. Let's see what you can, see what we can do, and that'll tell me what we need to do next. Okay. What's the square root of 16? Well, let's see. Let's just try something. Let's see. Now, most people that understand the square root will get this pretty quickly, but we'll just have, square root of 16 equals, I'll say 7. Okay. Well, okay, first of all, say 7. I don't think anybody would make that guess, but say 7, you check it. Okay. Okay, well, then say square root of 16 is 4 because 4 squared equals 16, right? Okay. Now, what's the square root of a squared? What would you square to get a square? What do you think? Okay, now that doing this with symbols can be a little confusing. Let's skip these for the moment. And tell me what's the square root of 5 squared? What's the square root of 5 squared? So it's still a little uncertainty, so give you the hint. Okay. Now let's see, square root of 5 squared is the square root of 25. And what's the square root of 25? Well, it's a number you would square to get 25, and that's 5, just like the square root of 16 is 4. Okay. Just say changing the order of this problem so I can write the 4 up here. Okay. Because I don't want square root of 16 equals 7 here. Okay. So square root of 16 is 4, square root of 25 is 5. Okay. So you could say then that the square root of 5 squared is 5, right? Because what's the square root? The square root is what you multiply by itself to get the number here, right? What do you multiply by itself to get 5 squared? Clearly, you multiply 5 by itself to get 5 squared. Okay. So what's the square root of the square of -5? Okay, so square root of 5 squared, you multiply, you square -5, and you get 25, and the square root of 25 is 5. Okay, so let's see. Square root of 5 squared equals 5, right? But if you square -5, you take the square root, you don't get -5, right? Okay, well, with that example, what would the square root of a squared be? In other words, what would you square to get a squared? Okay, the square root of a squared, the usual answer I get, and the answer I would have given when I was taking algebra, obviously ought to be a. Okay. Took me a little while to understand because I didn't get a real good explanation. My teacher was very good. I usually got good explanations. So I had to figure it out. Um, Square root of a squared isn't necessarily a because, for example, the square root of -5 squared is not -5, right? It's 5. Well, we can fix that by putting absolute value signs around the a. So now the square root of a squared is the absolute value of a, and that takes care of it. If a is negative, you're still going to get a positive square root. And the square root always has to be positive. Okay? Okay. Now, what about the square root of a to the fourth, b to the sixth? What would you multiply by itself to get a to the fourth, b to the sixth? Okay. Looking at a to the fourth, b to the sixth. Okay. Now, one answer I've seen is absolute value of AB. Now that's good because you got the absolute value on it, right? But the absolute value of AB, well, if you square AB, AB quantity squared by the laws of exponents is equal to a squared b squared. And that's not a to the fourth, b to the sixth. Give it another try. What would you put into the parentheses here if you want the square to equal a to the fourth, b to the sixth? Okay, now the answer I often get is something like a squared b to the fourth. That's not quite so. A squared b to the fourth squared is a squared squared times b to the fourth squared, which equals a to the 2 times 2, b to the 4 times 2 by the rules of exponents, which you need to thoroughly review to understand this section. If you don't, some people got this, some people didn't. Okay, so not sure that's one of the ones I saw, but that's an example. Now this completed would give you a to the fourth, b to the eighth, right? Well, correct answer here is A squared B cubed squared. This gives you A to the 2 times 2 times A to the 2 times 3. Gives you A to the 4th, A to the 6th. Not B to the 6th. Okay. So square root of A to the 4th, B to the 6th is absolute value of A squared B cubed. I multiply A squared B cubed by A squared B cubed, I get A to the 4th, B to the 6th. Okay. Now again, we've got to be real careful about the rules for exponents. Okay. Let's try. Okay. Now, this is square root of A cubed, and my correction on the 3 did not work out, so I'm gonna have to rewrite it. Do what I wanted to. Okay. Square root of A cubed. Well, it's the square root of A times A squared. Why would I write it that way? Because now I can write this as a square root of A times the square root of A squared. And that equals the square root of A times the absolute value of A. Usually we'd write the absolute value out in front. And of course, I could switch the order of the multiplication. Okay, now you see what's happened here? Why did I express this as A times A squared? Of course, A times A squared is A cubed. Well, what I did was I took the highest even power of A that was less than 3. Okay, why did I take an even power? Because when you take a square root of a power, you're going to cut the power in half. The examples we just did show that. So you can't cut 3 in half. Okay, you don't get a whole number. All right, you'll get an integer. Okay, so let's just see if we can do this. Root of A to the 7th. Okay, what's the absolute value of A to the 7th? Now, everybody correctly said, okay, that's going to be the square root of A times A to the 6th. Okay, well, that can be separated out to the square root of A times square root of A to the 6th. Now, the square root of A is just the square root of A. Unless you know more about A, there's nothing you can do to simplify the square root of A. But the simplified square root of A to the 6th. Okay, well, what do you multiply by itself to get A to the 6th? Okay, let's say. What do you get if you square a squared? Matter of fact, let's just write several of these down. A squared squared is what? What's a cubed squared? What's a to the fourth squared? What's a to the fifth squared? And just put this in the context with rules of exponents. What's a cubed to the fourth? What's a to the fifth cubed? Write these down one at a time and see if you can tell me what the results are. The camera went out of focus. Just continue. I'm just going to say what I said before. Square root of a to the seventh. People correctly said is square root of a times a to the sixth. Square root of a times a to the sixth is the square root of a times the square root of a to the sixth. So what's the square root of a to the sixth? Okay, well, let's just recapitulate a little bit about the rules of exponents. Okay, what's a squared squared? What's a cubed squared? Okay, each of these, and put it all in context. What's a cubed to the fourth power? What's a to the fifth to the third power? Okay, so a squared squared, we multiply the exponents, we get a to the fourth. A cubed squared is a power of a power. We multiply the exponents, we get a to the sixth. Similarly, a to the fourth squared would be a to the eighth. A to the fifth squared would be a to the tenth. And now I threw a couple more in here just to make sure you weren't automatically just doubling the numbers. You know, because you double this, you double this, you double this, you double this. Because in each of these cases you're squaring, but here now a cubed to the fourth. Well, you got it. Okay, everybody got it. That's a to the 3 times 4, and you should write out the rule. Show the rule. If you're not writing it out, you're not reinforcing it. This would be a to the 5 times 3, which is a to the 15. Now, I'm going to remind you of something, that this ought to be part of what everybody knows always when they're trying to do algebra, okay? A squared times a cubed means a times a multiplied by a times a, which equals a times a times a times a times a, which is a to the fifth. A squared cubed means let's write it out. A squared times a squared times a squared, which equals a times a multiplied by a times a multiplied by a times a, which equals a times a times a times a times a times a, which is a to the sixth. Now we're doing that. Yeah. Okay. Now I'm 99.9% sure we did that because I always do that when I do exponents. Okay. But this is what shows you the difference between where you add the exponents and multiply the exponents. So this rule says that a squared times a cubed is a to the 2 plus 3, which is a to the fifth. A squared cubed equals A to the 2 times 3, which is A to the 6th. From just that example, if you remember that example and write it out, if you ever need to test whether you are going to add or multiply exponents, this alone tells you. Doing a power of a power, because of the way this works out, you're going to have to multiply the exponents. The way this works out, you're just going to end up having to add the exponents. This tells you how many A's you got, multiplied by how many A's you got. Okay? So if you know how many here and how many here, you add those numbers, and that tells you how many A's you got. Here, you got 3 groups of 2 A's. You got 3 groups of 2, that means you got 6 of them. So you're going to get A to the 6th. All right. You really need to understand all this and the rules of exponents to do this section. Okay? You're doing okay here. Picking it up. Now, question is, what's the square root of A to the 6th? You ask the question, what do I multiply by itself to get A to the 6th? Okay, got a good answer. Another way to say what I just said is, what do you got to square? What do you have to square to get A to the 6th? You got to square A cubed. Now there's a caveat. If A is negative, A cubed is negative, right? Because A cubed is A times A times A. You'd be multiplying a negative times a negative times a negative, which would give you a negative. So we're going to have to put absolute value signs around that A cubed. Or you could put absolute value signs around the A and then cube it. Be okay either way. Let's look at another example. Actually, I can't do that example with square roots. Okay, so I'm going to stick to square roots. Okay, so let's try now. Square root of 50. Okay, now you might need to review prime factorization. Square root of 50 is square root of 2 times 5 times 5. Now, prime factorization. Of 50, we start out writing 50. We divide 50 by the smallest number we can, which is 2. And 2 goes into 50 25 times. So 50 is the same as 2 times 25. 25 is the same as 5 times 5. So 50 is the same thing as 2 times 5 times 5. All these numbers are prime. They can't be divided by any other number except 1. Okay? So we have 2 times 5 to the square root of 2 times 5 times 5. Of course, we could write that as a square root of 2 times 5 squared. Divide that, or not divide it, but separate out the factor, square root of 2 times the square root of 5 squared. And we get 5 times the square root of 2. You let me give you one to work. Right. Square root of 72. Do the prime factorization of 72. Start out by doing the prime factorization. Okay, now everybody did the prime factorization of 72 correctly. That's the square root of 2 times 6 times 6. Okay. Now you write that as the square root of 2 times 6 squared, and go ahead and finish it. Okay. So square root of 2 times 6 squared is 2 times the square root of 6 squared, which is the square root of 2 times 6, which we're going to usually write in the reverse of that order. Okay? Okay, try this one. Try the square root of 8. A little bit of twist here. Okay, now that was nicely done. This prime factorization of 8 is 2 times 2 times 2. Of course, that's the square root then of 2 cubed, which equals the square root of 2 times the square root of 2 squared. And now we take half the exponent of 2 to take the square root, and we get square root of 2 multiplied by 2, or 2 square root of 2. That's very well done. Everybody did that right. Okay. Okay. Now let's mix up some numbers with symbols. Let's think about the square root of 32 x to the 5th. Now, it's not unusual for somebody to see this, say, what the world am I going to do with this? No, just to give you a start in case you need it, I would just take the numbers and the symbols, separate them into the product of 2 square roots. Now you know what to do with the numbers. Do what you did over here. Okay. And you know what to do with the symbols. If you remember what we did just a little while ago. Okay, so let's do this. Okay. So this throw people sometimes. You just treat the square root of 32 and the square root of x to the 5th separately. What do you do with the square root of 32? You do a prime factorization. And you're going to find that the square root of 32 is 2 to the 5th. Square root of x to the 5th, as we've done before, we separate out the highest even power of x. Because then we can take half that power. And we'll do the square root. Okay, well, this then is square root of 2 times 2 to the 4th, multiplied by the square root of x times x to the 4th. Okay, just ignore the x's. Square root of 2 times 2 to the 4th is the square root of 2 times the square root of 2 to the 4th. And now ignore this. Square root of x times x to the fourth is the square root of x times the square root of x to the fourth. Square root of 2 to the fourth is 2 squared. Square root of x is just square root of x, and square root of x to the fourth is x squared. Now, you might want to put absolute value signs around x squared. As of course, it's a square root, but x squared is automatically positive. It can't be negative. When you square a number, you always get a positive. So you don't really need the absolute value signs there. But if it was like the square root of x to the sixth, you would need the absolute value signs. See, think about that. Open math will help you address that. So we end up with 2 squared times the square root of x times square root of 2 times the square root of x squared, which we can write as 4 square root of x. Got that in bad order, I'm sorry. Okay, we write the square root of 2 and the square root of x, and then that's times 2 squared times x squared, which equals then square root of 2x multiplied by 4x squared, and we write that in more standard order with the square roots on the end. Square root of 4x squared times, 4x squared times the square root of 2x. Now you see ample examples in open math, but we've touched on all the techniques you need, okay? So you want to put them together, and then you probably want to practice them some.